Alright guys, now we're going to look at section 5.2. We're going to talk about what's called the side-side-side triangle congruence theorem. We write that shortly as SSS. So what it says is if three sides of one triangle are congruent to the three sides of another triangle, then the triangles are congruent. So we've talked about how if you have congruent triangles, then the three sets of sides are congruent and the three angled pair sets are congruent. We can actually say that triangles are congruent by just knowing that all three sides are congruent. So then from there we could determine the angles would have to be as well. So today we're going to decide if triangles are congruent by the side-side-side triangle congruence theorem, short as SSS. So in the first example, I have triangle ABC and triangle EHS, and we're going to determine if each triangle pair is congruent by SSS. If they are, we're going to list the sets of congruent sides. If not, we're going to explain why. So I'm going to get my highlighter here. I have side AB has one tick mark, as does side EH, which tells me that they are congruent. So as of right now, I know that AB is congruent to EH. We've got two tick marks here and two here. So now I can see that BC is congruent to HS. And then three tick marks and three tick marks. So I know that the first triangle here. Side CA would be congruent to side SE. So now what I can say is by the side-side-side theorem, so by side-side-side, triangle ABC is congruent to triangle. Now remember here that the order does matter. So I went from A to B, which was the side that had one tick mark. And then we followed along B to C, which had two tick marks, and then from C back to A. So if I'm going to name that triangle ABC, I've got to follow the same direction on the second triangle. So I want to look for the side that goes, if you're looking at the colors, from this purple color over to the blue. So from E to H. And then we went along the blue to the pink. So we need to do the same here. Back to E. Or another way to look at it is along the first tick mark to the side with 2, to the side with 3. So over here I would go 1, 2, 3. Okay. So these triangles are congruent by side-side-side. Second example, I have triangle LMN and DEF here. Whoops. So let's start looking at our sides. I don't have any mark along this side, which means I can't conclude that it's congruent to any of the other sides on the other triangle. I can say that MN is congruent to EF, and that LN is congruent to DF because they have 3 tick marks and 3 tick marks. But again, this third side, so the one I have here in red, I'm going to change it to green actually. Okay, so this side here, because there's no tick mark matching it to DE and there's nothing in the problem that tells me they're congruent, I cannot conclude that they are. So what that means is I have 2 sets of congruent sides, but in order to use side-side-side, I have to have 3 sets of congruent sides. So since LM is not given, oops, the pen here is acting up. Okay, so since side LM is not congruent to side DE, these triangles are not congruent. Which means I can't now say that the angles are congruent. In the previous example, I could say that. And we'll talk more about that in the next one. Alright, so we've got two more examples. These ones have numerical values. Theorem works the same though. So if I look at my first triangle, I have this side 28 inches. And if I look at the second triangle, I actually don't have anything labeled as 28 inches. So I right away can say that these triangles are not congruent by side, side, side. In order to use side, 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 all three sets of sides would have to be congruent. So I do have the 38 and the 38. And then I've got 54 and 54. But again, we've got this 28, which is not the same as 32. Sorry. My pen's not working. Come on. Alright, so since MN, oh my gosh. It's taking way longer than it should. Okay, so since MN is not congruent to QR, then we can say that these triangles are not congruent by SSS. I'm going to abbreviate because this pen is driving me crazy. Triangles. Oh my gosh. There we go. Okay. Alright, so looking at my next example, we've got 8 and 8. And then here's where you have to be careful. I know this one is 10, so you might want to say that KL is 10, but you can't. We have nothing in the problem. There's no tick marks to say that it's 10, that it's congruent to WX. There's no label. Same with the 12 side over here. I have nothing to say that it's congruent to this side YX. So, as my explanation shows in the previous problem, I'm not going to write it out because this pen's driving me crazy, but it's kind of the same idea. We have that JL is not congruent to WX or YX, and then KL is not congruent to the other side either. So since we don't have three sets of congruent sides, we cannot say they're congruent by SSS. Alright, one thing you want to watch out for too is this. When your triangles share a side, you got to remember that any side is congruent to itself. That's actually called the reflexive property. So reflexive, like reflection in the mirror, it's still you. Reflexive property. That's a me. There we go. So if I look at my triangle here, RT would be congruent to RT. So in terms of the triangles, I would want to mark those sides as congruent. So SR is congruent to TQ here. RQ is congruent here to ST. So I've got my three sets of congruent sides. Those be a light color. Here you go. Nope. Okay. So again, the idea is that purple is congruent to purple, pink is congruent to pink, and then the blue is congruent to itself. So these triangles would be congruent by SSS, and our direction said to write out the congruent statements. if I can get my pen to work. Alright, so RS is congruent to nope. This is frustrating. Okay. And then ST is congruent to QR. And then our third side, RT is congruent to itself. Now if you write this as TR because you're going by the direction of the triangles, that's fine too. So by SSS, side, 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 these triangles are congruent. So remember the order matters. So I'm going to go along here 1, 2, 3. So that would be RST. Congruent to triangle, same direction, 1 to 2 to 3 would be TQR. Okay. Again, the order of those letters does matter. Alright, last one. So determine the value of x that would make these triangles congruent by SSS. So I've got this 25 congruent to this 25, and actually this ends up being an isosceles triangle. So you have two sides in one triangle that are both 25, same in the second. So if these triangles are going to be congruent by side, 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 I would need this third set of sides to be congruent, which means 9x minus 21 would have to equal 15. And then solve for x. So I'm subtracting 21, so do the opposite and add. Divide both sides by 9. X would equal 4. You can check your work. Do 9 times 4 minus 21 and you will get 15. Okay, so as before, if you have any questions, pause the video, tell me at what time you got stuck so I can refer back to the video and help you out. Okay, bye for now.